Before you run ANOVA, there's a question you need to answer first. Do your groups actually have equal spread? Look at the data. Group A is tight. All the points cluster together. Group B is all over the place, massive spread. And Group C is very tight too. The Brown-Forsyth test. It checks whether your groups have equal variances, and unlike other tests, it's robust to outliers and skew. The key idea, use the median. For each group, you find the median, not the mean, the median. Here, it's 12.5 for Group B. Then you measure how far each point is from that median. Those yellow lines are the absolute deviations. Z equals the absolute deviation from the group median. You do this for every single group, and then run a standard ANOVA on those Z values. If the Z values differ significantly across groups, the variances are unequal. Why the median and not the mean? Because outliers don't distort the median. One extreme value can pull the mean way off, but the median stays put. That's exactly what makes Brown-Forsyth more robust than Levine's test, which uses the mean instead. The test. Run a one-way ANOVA on the Z values. The average absolute deviation for each group, A is 1.3, B is 3.9, C is just 0.9. Group B clearly has much more spread than the others. The F statistic comes out to 20.83, with a p-value less than 0.001. Highly significant. What happens with an outlier? 5 data points, mean and median, both sit at 10. Now add an outlier at 30. Watch what happens. The mean jumps all the way to 13.3, but the median barely moves, just shifts to 10.5. Bartlett's assumes no outliers at all. It would break here. Levine's uses that shifted, mean, so its deviations get biased. But Brown-Forsyth uses the stable median. The outlier barely affects it. That's what robustness looks like. When to use it? Use Brown-Forsyth before ANOVA to check equal variances, especially when you have outliers, skewed data, or unequal group sizes. It handles all of that gracefully. If your data is perfectly normal with no outliers, Bartlett's test is actually more powerful. But honestly, that's rarely the case in practice. Try it free at metricgate.com.